Kuwait is a country located in the Middle East, on the northern edge of the Arabian Peninsula. The country has a coastline along the Arabian Gulf, which provides it with access to maritime trade routes and oil export facilities. Joseph Gallagher International played a critical role in the construction of the Emergency Sea Outfall (ESO) as part of Kuwait's Al Hayman wastewater treatment project. This project, initiated in 2020 through a joint venture with Al Hassanain, is part of one of the largest wastewater treatment initiatives in the Middle East, and indeed the world, valued at $1.6 billion. The emergency wastewater outfall involved the construction of a 6.2-kilometer long sea outfall of 2.4 meter and 2.2 meter diameter, making it one of the longest and largest pipe-jacked sea outfalls in the world. Joseph Gallagher International was responsible for deploying advanced micro-tunneling techniques to create 3 tunnels, including a 2-kilometer tunnel under the coral seabed of the Arabian Gulf. The open-cut trenching method of pipe laying was used up to the point where critical infrastructure needed to be crossed. The trench is excavated to the required depth, wide enough to accommodate the pipeline structure. The sides of the trench were stepped and battered to prevent collapse, and the bottom of the trench leveled and completed to provide a stable base for the open-cut pipe laying. A headwall was integrated into the trench to ensure the structural integrity needed at the tunnel exit, where the TBM was removed. The remainder of the pipeline to the sea outfall was constructed by Joseph Gallagher International using innovative solutions to optimize the project. Prior to starting construction on projects like this, environmental impact assessments are carried out to identify and mitigate potential harm to the environment. This can include preserving natural habitats, managing waste, and protecting water resources, thereby ensuring that development does not cause long-term environmental damage. Secant piles are constructed through a systematic process that involves drilling overlapping concrete piles into the ground. A series of primary piles and secondary piles are drilled into the soil or rock using specialized equipment. These piles, combined with a capping beam, serve as the ground support to enable the shaft to be safely excavated. On completion of the excavation, a reinforced concrete base is constructed, and the tunneling equipment is set up in the shaft. The tunneling machine is lowered into the shaft and is pushed forwards by hydraulic jacking rams to start the tunnel span. The first jacking pipe is then jacked forward as the excavation at the front of the machine continues. After the first jacking pipe has been installed and the jacks are retracted, the next pipe is lowered onto the jacking rig and then pushed forward. This process is repeated until all pipes are installed, forming the permanent tunnel lining. An overview of the project shows the open-cut trench and the exit point for the first TBM with the reinforced head wall. The first tunneled section of the pipeline crossed under a highway, leaving room for future additional construction and infrastructure. Once this span was completed, the TBM was lowered into the same shaft to tunnel towards the second shaft, thereby connecting them with a continuous pipeline installed on the correct grade. The TBM was then moved to the landfall jacking shaft, where it tunneled 2 kilometers to the predetermined outfall position. At the pre-prepared exit trench, which was backfilled with sand for the arrival of the tunnel boring machine, an excavator and crane barge was maneuvered into place by tugboats for the marine recovery of the TBM. The TBM was remotely disconnected from the pipeline by divers. Airbags fitted to the lifting beam were inflated under controlled air pressure to provide additional lift to assist the crane in raising the lifting beam and TBM to the surface. Due to the shallow depth of the Arabian Gulf, the size of crane barges and pontoons was restricted, so the TBM was towed 39 kilometers by 2 tugboats, chosen for their shallow draft and maneuverability to safely navigate the TBM through the shallow sea. The completed tunneling pipeline was required to transition into a 310-meter long HDPE diffuser pipe to ensure minimal environmental impact from the outfall of the discharged water. The HDPE diffuser pipe was fabricated onshore on a rail system that allowed for a smooth transition to the sea to allow it to be towed by tugboat to the required position. The accurate alignment of the HDPE pipe and diffuser sections was crucial to the butt welding process required to join each length of pipe. HDPE, high-density polyethylene butt welding, is a process used to join HDPE pipes or fittings through a method of heat fusion. The process creates a strong, durable and leak-proof joint by melting the ends of the pipe and pressing them together. The pipes or fittings to be welded must be properly aligned in a welding machine. The machine is capable of securely clamping the pipe ends, ensuring they are in perfect alignment. The pipe ends must be cleaned and free of dirt, dust, grease and contaminants. The ends are trimmed using a rotary pipe trimmer to ensure both surfaces are smooth and square. A specially designed heating plate, often coated with a non-stick surface, like PTFE, is placed between the pipe ends. The heating plate is set to the required fusion temperature, usually between 200 to 230 degrees Celsius, depending on the material and pipe diameter. The ends of the HDPE pipes are brought into contact with the heating plate under controlled pressure, allowing the material to soften and melt. Once the correct level of melting has been achieved, the heating plate is removed quickly but carefully to avoid any cooling of the pipe ends. The molten pipe ends are then immediately pressed together under a predetermined pressure to create a bond. The pressure must be maintained evenly across the entire surface to avoid air pockets or weak spots. The pipes remain clamped under pressure for a cooling period to allow the material to solidify and form a homogeneous joint. An adapter ring designed to securely connect the diffuser pipe onto the leading pipe of the tunnel is built into the first section of the diffuser. A bulkhead is bolted onto the ring to prevent permanent flooding of the line, along with a towing attachment frame designed to take the towing force without damaging to the pipe. The diffuser outlets were blanked off with blind flange plates and securely bolted, preventing flooding and entry of any debris during transportation of the diffuser pipe. The partially assembled diffuser, complete with airbags to prevent the rotation of the diffuser pipe, was carefully transitioned into the sea with the rail system and predetermined anchor points in case of bad weather, and then towed by tugboats to an intermediate area for the addition of concrete ballast weights. The precast concrete ballast weights were fitted to the diffuser line with a crane barge and a specially designed lifting frame to enable the ballast weights to safely be fitted on the floating diffuser. The lifting frame accurately positioned the ballast weights on the diffuser line at calculated points to ensure even distribution of the weight. The ballast weights were joined together over a rubber lining that provided a friction fit on the line to prevent movement. Each ballast weight was fitted with a pair of airbags to maintain buoyancy. The diffuser pipe was then towed to its final position above the tunnel mouth. A contingency of prepared anchor points was made in case of inclement weather, allowing for safety of the diffuser line in rough seas before final positioning. On arrival, the valves of the bulkheads were opened to allow the diffuser line to slowly flood and be lowered into the seabed. The controlled flooding of the diffuser line and controlled deflation of the airbags allowed the diffuser line to be accurately positioned at the mouth of the tunnel. A series of temporary anchor blocks and coordinated tugboat maneuvers ensured that the diffuser remained in the correct position. Divers proceeded to bolt the diffuser onto the leading pipe that was designed to have watertight fit to the TBM and subsequently the diffuser pipe. The blanking flanges were then removed and duck-bill diffuser valves were fitted to allow the discharge water to diffuse into the surrounding seawater with minimal environmental impact.